Okay, in this video we're going to talk about the law of cosines, and much like the law of sines, you use the law of cosines to find missing sides and angles of triangles when you don't have a right triangle. Law of cosines is much more difficult than the law of sines. So anytime you have a triangle and you figure out you're going to have to use one of these laws, you always want to look first to see if you can use the law of sines. Well, if you look at this, to use the law of sines, you must have one full proportion. You must have one angle and one sine from across, and from none of these, here I have angle A but I don't have side A. I have side C but I don't have angle C. I have side B so I don't have angle B. So I could not set up this problem using the law of sines. In your notes it says two hot air balloons approach a landing field. One is 12 meters from the landing point. A is your landing point. And the angle in between your two is 70 degrees. How far apart are the hot air balloons? So we're looking for A. So we're going to use our law of cosines to find this. Alright, so if we're looking for A squared equals B squared plus C squared minus 2BC cosine of A. We don't know A. So let's see. I know B squared. I'm going to do 17 squared plus 12 squared minus 2 times 17 times 12 times the cosine of A, which is 70. Alright, so if I start plugging this in, I get 289 plus 144 minus minus 408 cosine of 70. So, when I do these, let's see, 289 plus 144 gives me 433. And then over here, 408 times the cosine of 70 gives me 139.54. Okay, so now I can just subtract them. Remember, I'm looking for A squared. So I give 433 minus 139.54. I get A squared equals 293.46. 46. Keep in mind, that's A squared. I'm looking for A, so kind of like in the Pythagorean theorem, you have to go back at the end and take your square root, and you're going to get that A equals 17.13-ish. So the distance from between the two hot air balloons we find to be 17.13. Again, by using this law of cosines. Now, the nice thing about the law of cosines is that, much like with our friend the Pythagorean theorem, you can rearrange it. So the law of cosines says that for any triangle ABC, A squared equals B squared plus C squared minus 2BC cosine of A. That's the one we just used. Or, if what you're missing is B, B squared equals A squared plus C squared minus 2AC cosine of B. Or, C squared equals A squared plus B squared minus 2AB cosine of C. Rearrange the formula to fit the needs of the problem. Now, of course, sometimes you're missing things like the cosine, but you're still able to rearrange this dependent upon A, B, or C. So rearrange your formula to fit your problem. So let's do another one. So this one, in your notes, says find all parts of the triangle. So again, you want to look and see, can we use the law of sines? Well, again, to do law of sines, you must have both an angle and a side. And if you look, we have angle C, but not side C. We don't have angle A, but we have side A. We don't have angle B, we have side B. So we can't use law of sines. We're stuck with law of cosines. But this time we're going to use the one that starts with C squared. So we're going to use this way this time, because that's what we know. So, if we plug it in, I'm going to do 3 squared plus 2.5 squared minus 2 times 3 times the cosine of 28. Alright, so we end up with 9 plus 6.25 minus 15 times the cosine minus 13.24. So 9 plus, oops, minus 13.24. So we find out that c squared equals 2.01. And when we take the square root of that, we find out that c equals 1.42. Alright, so now we know this. So now your job, when you come to class tomorrow, is to find these other two angles. You can do it one of two ways. You can use this law of cosines, but of course you need to rearrange it and use your formula differently. Or now you can use the law of sines, and that would be how I would do it because it's actually a whole lot easier.